So this is a problem for partial pressures and involving mole fractions. So the problem is number 74 off the back of chapter 5, and so we have a deep sea mixture that contains 2 grams of oxygen for every 98 grams of helium. What is the partial pressure of oxygen when this mixture is 8.5 atmospheres? So we have 2 gases that make one mixture of 8.5 atmospheres. So we want to know what part is the oxygen's pressure. So the first thing we need to do is determine the percentages of each in the mixture. And we're going to do that using mole fractions. So the first part of a mole fraction is to find each contributing part's moles. So we have oxygen and helium. So we're going to have to convert our 2 grams of oxygen to helium. 2 grams of oxygen into moles of oxygen. So notice how I wrote O2, because remember oxygen is one of the diatomic elements. So we have to convert this using 1 oxygen is 16 grams per mole, so 2 oxygen is going to be, or 2 oxygens together are going to have a total of 32 grams per mole. So when we calculate that out, we get 0.625 moles of O2. Now we're going to do the same thing with helium. So helium has 98 grams, and this molar mass is, helium is not a diatomic, so we're just going to pull the number right off the periodic table, and it's a little over 4 grams per mole. So we have a 24.48 moles of helium. So now we know the total moles. Remember, we can't use grams because then it'd be 100 grams, and that's not what we're looking at. We're looking at moles because all of what goes into PV equals nRT and all these calculations were based off moles. So we have moles of O2 and moles of helium, and they're both the gas. And we know together they make 8.5 once their pressures are added together. So we want to know the individual pressure of oxygen. So now we have to figure out what percent by mole is oxygen, and that's the mole fraction. So the mole fraction X of O2 is going to be the moles of O2 over total moles. So we have, it's like a percentage. So it's going to be the over the total, which is going to be the 625 plus. And when you add it up and divide it out, you get a number around 254. Now, this is our mole fraction of O2. So we have to, now it's like a percent of the pressure. So the percent of the pressure is going to be 8.5 would be the total, and we only need oxygen's contribution. So we just multiply by the mole fraction. And that gives us oxygen's partial pressure of only 0.022 atmospheres. So we need like the oxygen's pressure of oxygen, right, is 0.22 atmospheres. So when you look at a problem with partial pressures, you need to first figure out the moles of both of them to figure out, or if there's 3, you could have added 3 numbers down here, and you want to put the mole, the partial pressure you're interested in, and the moles of that will be the numerator, because that will be that's percentage. And then you simply just multiply it by the total pressure of the system.